Hello everyone, myself Saurabh Shukla. This is a course CAD for VLSI design. In our first part, we already seen evolution of CAD tool. In our second part, we seen CAD terminologies. If you are having any doubt, you can watch the videos. If you are having any doubt, you can ask, you can comment. Okay. Now we are going to see design flow. It is a third part. Now we are going to see design flow. The process of converting the process of converting an idea to a chip is called VLSI design process. Means if you are having any idea and you want to make your idea in a chip, if you want to make your idea in a chip, then this is known as a VLSI design process. Then this is known as a VLSI design process. Idea can be anything. Idea can be anything. Like suppose I am a lab in charge. We can take one example. I am a lab in charge, and my daily routine is that every morning I am coming to the lab, and first I am opening the door of the lab, then switch on all the lights, then fans and AC, whatever the required switches are there, I am putting every day, I am putting on. And when I am going outside of the lab, first I will switch off all the switches like light switch, AC switch, fan switches, I am putting off, then I am closing the door and going back. Okay, this is my daily routine. Suddenly the idea came in my mind that this is my daily routine. This is my daily routine. I want to convert this thing in a chip. It should be automatically. What the work every day I am doing, that is a manual work. Like I am coming in a lab, opening the door, and then switch on all the lights. While I am going outside of the lab, I am switch offing all the lights and closing the door and going outside. Okay, that's suddenly an idea came in my mind that whatever the work I am doing daily manually, can I convert this one as a automatic? Like whenever I will enter inside the lab, automatically the light should get on, fan should get on, and AC should get on. And whenever I will leave the lab, then all the switches should get off and the door should get closed. Okay, this is my idea. I want to convert this manual work in a automation, in a automatic work. Okay, suppose I am opening the door, automatically the light, fan and AC should get on, and whenever I am going outside of the lab, the all the lights and fans and AC should get off. This is my idea. Okay, understand this thing. This is my idea. I want to convert my manual work in a automatic automation. Then what is the requirement? If I know the VLSI language, if I know the VLSI language means if I know the HDL language, then I will write a program. Then I will write a program in a HDL language. Okay, then I will verify that one. Then I will verify that one that it is working properly or not. Then I will convert in a chip. Then I will convert in a chip. So what is the process? Process is three steps are there. First one is a whatever my idea is there, for that thing I will write a logic. That logic is a program. Then I will verify that one, that my logic is working properly or not, that my logic is working properly or not. Then if it is working properly, my logic is working properly, then what will I will do? I will convert that my program in a chip. Okay, this is a design flow. This is a design flow. The second point, VLSI design process involves a sequence of a step and flow. Means this is not a single step things like in a VLSI design. It is not a single thing that you have written something and you are going to convert your idea in a chip. There is a so many steps are involved. So many steps are involved. Like first you have to write the program, then you have to verify, then you have to then if your program is working properly, then you are going for the synthesis process. Okay, so many steps are involved, so many small steps are involved in a design process, VLSI design process. The tools the tools that enable the design process are called CAD 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 tool for the VLSI, CAD tool for the VLSI. Okay, what the mean by CAD? CAD is a computer aided design. CAD is a computer aided design. So I think that it is clear what is a design flow. Design flow is a very simple thing. Whatever the idea you are having, you are going to convert this idea in a chip. Okay, I taken as a one example that suppose I am a lab in charge and I whatever my daily routine is there, I want to make my manual work in a automation. I want to make in a automation. Then whatever your idea can be anything. Your idea can be anything, and your idea is going to be converted in a chip. That is known as a design process. Okay. The next thing is HDL. The next thing is HDL. One by one we will see all the points. HDL stands for the hardware description language. HDL stands for the hardware description language. Okay, a language by which we are describing the hardware. Definition. Definition: a high level programming language used to model hardware. Used to model hardware. Your HDL is a high level programming language. Your HDL is a high level programming language used to model the hardware. Means a language by using a language you are making the hardware circuit. You are making the hardware circuit. But remember one thing, here the hardware circuit contains only the gates. Here the hardware circuit contains only the gates, not a capacitors and resistors is not there. Only the gates. Gates are AND gate, OR gate, NOT gate, NAND gate, XOR gate. Like these gates are there only in a circuit. Hardware description language have special hardware related construct. Construct means how many constructs are there, like AND gate, OR gate, XOR gate, NAND gate. These are the constructs are there. You cannot go for the resistor, transistors and capacitors. Okay. Currently model the digital system. And in a future can be model the analog system also. Presently whatever the VLSI tool is there, we can model only the digital system. Digital system means where the gates are only there. Gates, like all the gates are there. By using the gates you are going to be make the chip. Okay, presently we are having the digital system. For the digital system we are having the HDL language. For the analog system like a capacitor, the resistor and transistors, we are not having the any tool. We are not having the tool. Presently the scientists are working on this one, and in future within 5 to 10 years it is going to become in a market. For the analog system also the tool will be available. Can be used to build can be used to be build the model for the simulation and synthesis and test. Can be used to build the model for the simulation, synthesis and test. Means are different. For simulation purpose also you can write the model, for synthesis purpose also you can write the model, and for the testing purpose also you can write the model. Okay, here the two terms are there. One is a simulation, another one is a test. Simulation means first you are writing the program, then after whatever the program you have written, you are going to be verify your program is working properly or not. That is a simulation. Okay, test means after getting the hardware circuit, you are verifying, you are testing your hardware circuit. That is known as a test. Okay, simulation is a virtual thing. Means whatever the program, whatever the code you have written in your computer, that thing you are going to be verify. Okay, testing is also a verification, but it is a real time verification. Means whatever the hardware circuit you are getting, that one you are verifying. That is a testing. The last point, have been extended to a system design level. Means you can go up to the system level designing also. In a HDL language you can go up to the system level design also. If you are having any doubt, please ask me and comment. I am ready to help you. Okay, this is the end of the third part, and in the next part, fourth part, we will see why use HDLs. Thank you for listening.